This section, completing completing the square and quadratic formula, will be about another method of solving quadratic equations. Now we're going to talk about the in practice on completing the square first, and then we will solve using the quadratic formula. So what is completing the square? Completing the square is the algebra technique that takes a quadratic equations from the standard form ax squared plus bx plus c to the form ax plus d squared plus a certain number e equals 0, where a, b, c, d, and e are real numbers. So now, before we even go there, let's see how we can transform a perfect square trinomial to a perfect square expression to a quadratic expression. So it's already a quadratic expression, but you see how it's a binomial raised to the second power. So let's say instead how to transform a binomial to the second power to the quadratic format. Well, it's just to expand the square, right? To expand the square. So we have 2x minus 3 to the second power. The one thing that you don't want to do is you don't want to distribute the power over to both of them, because you should remember anything raised to the second power is the thing times itself. So that's why I wrote 2x squared, 2x minus 3 to the second power is 2x to the 2x minus 2 minus 3 times 2x minus 3. Now, if you FOIL this, you're going to have 4x squared times -3, -6x times another -6x times -3 times -3, that's +9. Combine these two terms, you will have a trinomial, but this trinomial will be a perfect square trinomial because you could write it as a binomial raised to the second power. So that's 4x squared minus 12x plus 9. Now with that, you see that there are some trinomials that can be written as either a product of a binomial times itself or a binomial raised to the second power. Now, how, when you have a trinomial this format, to identify, or what are the clues that you should be looking for to know whether a quadratic expression or a trinomial of second degree is or is not a perfect square trinomial? So I have 2 points that you need to watch. First, you need to check that both the quadratic and the constant terms, they are perfect squares. Number 2, the coefficient of the quadratic term and the constant term, they would need to have the same sign. They would need to have the same sign. And then third, the linear term must equal to 2 times the square root of quadratic term times the square root of constant term. Now, when you have that, you justify the fact that you have a quadratic expression that can be written as the square of the binomial. And in this case, what would be this? So as you can see, you see how this expression 2x can be written as the square root of 4x squared, right? And this sign is the same sign here too. So if it was a plus, then you would need a plus in for this one. And then 9 is 3 squared. So basically, when you have that, it will be, when you can have the middle term, when you verify all three conditions, then a quadratic expression like this will be written as a binomial square, where you can take it as the square root of the quadratic term, 2x, the sine of the linear term, minus in this case, and then the square root of the constant term, that is 3, and then raised to the second. So that's how you transform from quadratic to perfect square. Now let's see how let's practice on identifying whether an expression given is a perfect square, a trinomial is a perfect square trinomial or not. Now, number one, we need to check to see if the two are perfect square. They are. So that means I can write x the two are perfect square. I can write x, and then square root of 16 is 4. Now, before I know that we can have the square, we need to verify the middle term. If it's 2 times x times 4, that 2 times x times 4 is 8x, which is the same as the middle term. So that concludes since this the sign of the linear term is plus, I would put plus here because this checks with the middle term. So let's try another example. We have 25x squared and then 4. So I'm gonna put square root of 25x squared is 5x. The sign is negative. And then square root of 4 is 2 squared. That's what we have, but we're not sure yet until we verify that negative 20, or 20 if you want, will be 2 times 5x times 2, which is 20x. Also check. Let's see the next one. I have 9x squared, so that's 3x, negative sign, square root of 400 is 20. Now let me verify. The 2 is in the formula, 3x times 20. 2 times 3, that's 6x, and 6x times 20 is 120. So that's 120x. Also check. For this one, we have x squared and then negative 36. And you remember one of the conditions is that number 2 was the constant and the coefficient of the quadratic. They need to have the same sign. We don't have this condition, so this is not a perfect square trinomial. So I need to check yes, yes, and yes here, and this is no. And then last, we have same sign, perfect square for both first for quadratic term and constant term. So I can start writing this as x minus square root of 81 9 squared. And now let me check for to know that if this is true. So that will be 2 times x times 9, which is 18x. It works. So now we know how to identify whether a perfect square, a trinomial is or is not a perfect square, and how to write it as a binomial to the second power. Now, to complete the square, you may have the first two terms, like these two, of a trinomial, and then you need to know what it takes to replace, to find the third term, the constant of it. And that's completing the square. To complete the square, you need to find the constant term. So the constant term of a binomial that is the constant term of a trinomial of second degree is always given by b divided by 2 squared, with the condition that a equals 1. We have to make sure that the condition is a equals 1. In this case, if a is not 1, you're going to have to factor the a out. So if you have an expression like 5x squared plus 2x plus 7, so we will need to factor the a out, the 5 out, before we apply this b over 2 divided by 2. I mean, b over 2 squared. So we have to remember that a must be 1 in order to apply, to find the constant as b, the coefficient of the linear term, divided by 2. Well, in your notes, I mistakenly put an a here, so there's no a, it's b divided by 2 squared. Now, given that, we can complete the square for each of these. So find a constant that will complete the square for each of these situations. So b equals 12. So b over 2, b over 2 squared is going to be 12 over 2 squared, which is 6 squared, that's 36. So the constant term would be 36. This one, we got b equals 7 and a is 1, so we don't have issue. We don't need to divide by anything. So 7, b equals 7, and b over 2 squared would be 49 over 4. Here you have b equals 1/2. So b over 2 is going to be 1 over 4, right? Because it's 1 over 2 divided by 2 over 1. So that would be 1 over 2 times 1 over 2, which is 1 over 4. So when you square it, it's 1 over 16. So that's plus 1 over 16. That completes the square. And here b equals 2 square root of 3. So b over 2 will be, let me square it, it will be 2 square root of 3 over 2, that is squared. So that's square root of 3 over squared equals 3. So, and the perfect square would be here, square root of x squared is x minus sine, and then square root of 36, 6 squared. So that would be the square. And for this one, next one, number 2, it will be x, square root of it, sine of b is plus, and square root of 49 over 4 is 7 over 2 squared. You always want to put the square because that's the equivalent of this expression after you add the constant that will make it a perfect square. For this one, it will be x square root of x minus 1 over 4 squared. And here it will be x plus square root of 3 square root of 3 would be square root of 3 and square. So that's how you complete the square and put the expression in perfect square form. Now let's see how we can use the complete the square to solve equation. So now here are the steps, and while we're reading the steps here, we're going to practice on the other side of the table. So first step is making sure from the quadratic format, from the quadratic form of the equation, you need to divide both sides of the equation by the coefficient of the quadratic term so that the coefficient becomes 1. So in this case, quadratic term coefficient is 5. I'm going to divide both sides by 5. And the new equation becomes x squared plus 8 over 5x minus 4 over 5 equals 0. 0 divided by 5 is 0. So now that's a new equation that I have. Let's see step 2. Add or subtract in order to cancel out the constant term on both sides of the equation to keep variables only on one side. So we want to keep the variable terms on one side. And now in this case, we will need to subtract. We will need to add the constant on both sides. So let's add 4 over 5 on both sides. And the new equation is now x squared plus 8 over 5x equals 4 over 5. Now that we have the two terms here, we will complete the square by looking for the constant term, which you know that's b divided by 2, with b being this value, b being the linear coefficient, the term coefficient of the linear term, b divided by 2 squared. So let's see what they say. They say here, add on both sides of the equation the missing term to complete the square. Complete the square. So b equals 8 over 5. b divided by 2 squared will be 8 divided by 8 over 5 times 1 over 2, right? Because it will be 8 over 5 over 2 over 1. So that's the main fraction. So the top fraction, 8 over 5 times one, the second fraction, the reciprocal of the second fraction, or keep change flip, if you want to use this language, over 2. Now we can divide 8 by 2, that's 4 on top, so 4 over 5. So b over 2 is 4 over 5 squared, which is 16 over 25. Sixteen over 25. I just erased this because I want the space to put the equation. So now if you add the constant term on both sides of the equation, what you have here is you're going to have this equation, but we're going to add the constant 16 over 25 on both sides. Now we automatically have a perfect square trinomial on this side, because that's how, since you complete the square, you can easily set up your equation as this is the perfect square here. So how do you write the perfect square? We practiced it earlier. So that's going to be the square root of this, which is x. Then the sign of the linear term, in this case, plus. And then the square root of the constant term that you just added, that is 4 over 5. Then square equals. Now we're going to simplify the other side of the equation. That is 4 over 5, this one here, 4 over 5 plus 16 over 5 over 25. If we multiply by 25, sorry, if we multiply by 5, that would be the common denominator. 25 is the common denominator. So that's 20 over 25 plus 16 over 25. So that is 36 over 25. So that's what we get here when we combine 4 over 5 and 16 over 25. So that is 36 over 25. So that's what it says here. Write the trinomial as a perfect square on one side and simplify the other side of the equation. And then once we're done with that, it says solve the equation found in 4 using the square root principle. The square root principle is if you have u squared equals a, 2 solutions, that means you have 2 solutions, u equals square root of a, or u equals minus square root of a. In this case, on the other side, it's going to be x plus 4 over 5 equals square root of 36 over square root of 25. That's 6 over 5. Or x plus 4 over 5. Let me put it over here instead. Equals negative 6 over 5. So with that, we can go ahead and solve. We can go ahead and solve for x in each equation. So I'm going to subtract 4 over 5 on both sides. And then that cancels this. X equals same denominator 5. So we can have 6 minus 4. 6 minus 4 is 2 over 5. Now negative 6 minus 4 is negative 10. Negative 10 divided by 4, by 5. So that's x equals negative 10 over 5, which is negative 2. So your solution set using the complete the square is 2 over 5 and negative 2. By the way, if the first step, sometimes you don't have to do it, because if a equals 1, you will not need to divide by 1 because it's not going to change anything. You would jump straight to the second step. Solve the following equations by completing the square. Solve the following equations by completing the square. Use a comma to separate solutions. Step 1, we're completing the square. We would try to see if the coefficient of the quadratic term is not 1. If it's not 1, then we would divide both sides of the equation by the coefficient of the quadratic term. That's the quadratic term. The coefficient is 1, so we can go straight to the next step, that is isolating the constant term. Subtract 18 on both sides. So the equation is now x squared minus 6x equals negative 18. Next step, we will find the constant term that will make this expression a perfect square trinomial. The constant term that makes this expression a perfect square trinomial is 6, the linear coefficient, 6 divided by 2 to the second power. So that is 3 squared. That is 9. So we have 9 that we will add on both sides of this equation. So that is, the new equation is x squared minus 6x plus 6 equals plus 9 equals 18, negative 18 plus 9. We add it on both sides. So the 9, remember 9 was 6 divided by 2 squared. 3 squared is 9. So that's how you find the constant term that completes the square. Now, once we have the square, the trinomial, the perfect square trinomial, we can write it as a binomial squared. So that's the square root of the quadratic term, x, this sign, the sign of the linear term, minus, and the square root of the constant term, 9, squared equals negative 18 plus 9 is negative 9. Now we have an expression squared equals number. We can use the square root property to solve this equation, where we're going to have two solutions. X, first equation will be x minus 9 equals square root of negative 9, or x minus 9 equals square root of negative 9. Square root of negative 9 is square root of negative 9 is square root of negative 1 times square root of 9. Square root of negative 1 is I, imaginary number. And then square root of 9 is 3. So that's 3i. Square root of negative 9 is 3i. So that's x minus 9 equals 3i, or x minus 9 equals negative 3i. We add 9 on both sides. X equals 9 plus 3i, or x equals 9 minus 3i. Solution set is 9 plus 3i, comma, 9 minus 3i. Next example. Let's divide both sides by coefficient of the quadratic terms by 7. We get x squared minus 4x minus minus 315, negative 315 divided by 7. That is 45 equals 0. Now, after dividing by 7 on both sides, we have coefficient is 1. We can add 45 on both sides. We have x squared minus 4x equals 45. We will complete the square. X squared minus 4x equals 45. Now, what do we add here that completes the square is going to be 4 divided by 2 squared is plus 4. And then we add 4 also on the other side. So we can write the perfect square here, and that's going to be 49. Square root of x squared is x. Assuming that we just use the positive square root of x, assuming that x is positive. And then the negative sign, and then square root of 4 is 2. Now we can solve by using the square root principle. X minus 2 equals square root of 49, or x minus 2 equals negative square root of 49. Square root of 49 is 7, so x minus 2 equals 7, or x minus 2 equals negative 7. If I add 2 on both sides, x equals 9, or x equals, we add 2 on both sides, x equals negative 5, and the solution set 9, negative 5. Next, we can divide by 9 on both sides. X squared minus, we simplify by 3, that's negative 2x over 3, negative 2/3 x. I'm gonna subtract this over, so that is 4 over 9 on the other side. I divide and I use 2 terms at the same time. And then now let's find the constant that completes this square. The constant will be this expression divided by 2. So that's 2 over 3 divided by 2 over 1. Well, I mean, I say over 1 because 2 is 2 over 1. It's just 2, which is 2 over 3 times 1 over 2. That's the first keep. That's keep, change, flip. So you keep the top fraction, you change division to multiplication, and then you flip the bottom fraction. So we have that. And then we square this. That's b divided by 2 squared. Well, we can simplify 2, so that's 1 over 3 squared, which is 1 over 9. So we're going to add 1 over 9 on both sides. So that is x squared minus 2 over 3x plus 1 over 9 equals 4 over 9 plus 1 over 9. Now let's form the perfect square. This is going to be, since we have the common denominator 9, so that's 5 over 9 square root of x, and then this sign, square root of 1 over 9, that is 1 over 3. Okay, so now we can use the square root principle to solve this. That's going to be two equations, x minus 1/3 equals square root of 5 over square root, well, obviously it's just square root of 5 over 9, or x minus 1/3 equals negative square root of 5 over 9. Well, we can separate the square root. Square root of 5 over square root of 9, that is square root of 5 over 3, right? So we have x minus 1/3 equals square root of 5 over 3, or x minus 1/3 equals negative square root of 5 over 3. Let's add 1/3 on both sides. 1/3 on both sides. That is x equals square root of 5 over 3 plus 1/3, or x equals square root negative square root of 5 over 3 plus 1/3. Common denominator is 3. We can add the top. So x equals 1 plus square root of 5 over 3, or x equals 1 minus square root of 5 over 3. Your solution set is 1 plus square root of 5 over 3, or 1 minus square root of 5 over 3. Next, solve the equation 3x squared minus 4x plus 5 equals 0 by completing the square. Since the coefficient of the quadratic term is not 1, let's divide by this coefficient. We'll divide by 3. So we have this new equation that is x squared minus 4/3 x plus 5 over 3 equals 0. Now let's subtract, let's isolate the constant. So we're going to subtract 5 over 3 on both sides. So that is x squared minus 4 over 3x equals negative 5 over 3. Let's find the constant that completes the square. That's going to be 4 over 3 divided by 2, or 4 over 3 times 1/2. Cancel 2. That's 2 over 3. When we square it, it's 4/9. So that's 4/9. We add 4/9 on both sides of this equation. That's x squared minus 4/3x plus 4/9 minus 5/3 plus 4/9. This becomes a perfect square trinomial where that you can write as the square root of x is x. This sign minus then the square root of 4/9, that is 2/3 squared, equals common denominator is 9. So we would multiply this top and bottom by 3 to get the 9 in denominator. So that's -15 plus 4/9. So the new equation is x minus 2/3 squared equals -11/9. Now let's use the square root property to have two equations. X minus 2/3 equals square root of -11/9. Now, remember, when having a negative number inside of a radical with index even, it gives you a complex number. Or x equals x minus 2/3 equals negative square root of -11/9. Now let's solve for x. Let's solve for x. We can simplify this. Before we solve for x, let's rewrite this as a simplified expression. So that's x minus 2/3 equals I square root of 11/3. Basically, what I did is I write the square root of -11 over square root of 9. Square root of -11 is square root of -1 times square root of 11 over square root of 9, 3. This is I, and this is square root of 11. Since it's going to give me a decimal number, I don't want to deal with that. So that's going to be I, the square root of 11/3. So that's how I get this. So the other equation will be simplified the same way with a negative sign outside. So or x minus 2/3 equals -I square root of 11/3. Now we can add 2/3 on both sides. We can add 2/3 on both sides of each equation to isolate x. X equals, that is 2/3 plus I square root of 11/3, or x equals 2/3 plus minus I square root of 11/3. So we have this, and then combining the fractions, since we have a common denominator, we get x equals 2 plus I square root of 11 over 3, or x equals 2 minus I square root of 11 over 3. And the solution set is 2 plus I square root of 11 over 3, comma, 2 minus I square root of 11 over 3.